Hello everyone, welcome to CCNP Switch course prepared by NetworkL. Cisco divided the CCNP certification exam to main three parts, and they are switch, route, and T-shoot. And we are going to starting with the switch part, and this first section will be about the basic switching concepts. We are starting with the hub. A hub is a common connection point for devices in a network, and hubs are devices commonly used to connect segments of a local area network. The hub contains multiple ports. When a packet arrives at one port, it is copied to the other ports so that all segments of the local area network can see all packets. As you see that in the picture, we have a hub and we have 4 ports over the devices. If port 1 wants to communicate with port 4, for example, the packet is fluted to port 2 and port 3 as well. And as you can see that's an inefficient use of the bandwidth. The second device we are going to talk about is switch. A network switch is a computer networking device that connects devices together on a computer network by using packet switching to receive, process, and forward data to destination device. A network switch is a multi-port network bridge that uses hardware addresses to process and forward data at link layer 2 of the OSI module. And you can see a switch in here. This switch can be OSI layer 2 or layer 3 as well. If we are talking about a layer 3 switch, that's a multi-layer switch which can also make routing as well. Layer 2 switches make switching based on the MAC table. They keep a MAC address table and forward the packets between ports using that MAC address table. So that provides us efficient use of bandwidth, and these devices can also provide power over Ethernet and the security operations for us, which we are going to talk about later in detail. Let's take a look to the broadcast domain. A broadcast domain is a logical division of a computer network in which all nodes can reach each other by broadcasts at data link layer. A broadcast domain can be within the same local area network segment, or it can be bridged to other local area network segments. Any computer connected to the same switch is a member of the same broadcast domain. Further, any computer connected to the same set of interconnected switches is a member of the same broadcast domain. Please pay attention that routers and other higher layer devices form boundaries between broadcast domains, and separating VLANs divides broadcast domains as well. Let's take a look to the picture now. We have 3 broadcast domains in here, and as you can see that we have a boundary device which is a router in here. And also, VLANs are boundaries for the broadcast domain too. Let's take a look to the MAC addresses now. A MAC address of a computer or printer or something, any network device, is a 6-byte unique identifier assigned to network interfaces for communications at data link layer of a network segment. MAC addresses are used as a network address for most IEEE network technologies, including Ethernet and Wi-Fi. Logically, MAC addresses are used in the Media Access Control Protocol sublayer of the OSI module. An organizational unique identifier is a 24-bit number that uniquely identifies a vendor, manufacturer, or other organization. As you can see that the first portion of the MAC address is organizationally unique identifier. Other portion of the MAC address is universally administered address. Universally administered address is uniquely assigned to a device by its manufacturer, and that's it. And that's the second portion. Let's take a look to the Ethernet frame right now. Ethernet frame consists some fields, as you can see that in the picture. They are preamble, SFD, receiver MAC, sender MAC, an optional VLAN tag, and type field, payload, and CRC checksum. For example, let's take a look to the preamble first. Preamble communicates to the receiving devices whether a frame is coming and provides synchronization. The second field is SFD, which is start of frame delimiter. Start of frame delimiter is responsible for specifying the beginning of the destination MAC address in the next byte. And the other fields are receiver and sender MAC and an optional VLAN tag. And we have a type field in here. And we have payload, pad, and CRC checksum. Let's take a look to the basic switching process right now. If the destination MAC address is found in the CAM table of the switch sends the frame out of the corresponding port. This process is called forwarding. If the destination MAC address cannot be found in the CAM table, the frame is sent to all other ports in the same VLAN, and this process is called flooding. If the destination MAC address of the receiving frame is the broadcast address, which is FFFF.FFFF, this time the frame is sent to all the ports in the same VLAN, and this process is called also flooding.